Hello everyone, welcome to this episode on the basics of C++. So in this episode we will be just covering the basics of C++ like the variable types and how to compile your program and just getting set up. So let's dive into it. And so as you can see, I'm on a Mac and I'm using Xcode, but you can use Visual Studio Code or anything that you like. You can also compile it from command line if you uh, dig that. But yeah, I mean, I'm assuming that you guys have a compiler or IDE to work with. So I won't go into the details. If you guys don't have it set up, you can always comment down and I can help you guys with that. So yeah. So as you can see, uh, I have, let's go from the top, right? So first of all, any C++ code, any file for that matter, if I just delete everything, it's an empty file, right? It can be anything, and I can rename it as .cpp. But how will the compiler know to do what it does, right? So first of all, we need to tell the compiler we need to include some files. So when I say include bracket and put some stuff between it, it tells the compiler to to include all the libraries defined inside this, not the libraries, but all the functions and all the classes defined in the IOStream library. So it's, for example, let's assume, and it is true that IOStream is a library, right? So there are functions defined in IOStream and there are classes defined in IOStream. So what happens is that uh, all the functions, when you say include IOStream, all the functions that are defined in IOStream, they get uh, included here. So for example, there's one function, func1 defined, and there's another function, func2 defined. And when you say include IOStream, they get copied from the IOStream library to this. All right. So yeah, I will just my camera. It's just yeah, that looks a little better. So yeah, as you can see, when you include this, get that. Typically, if you don't use any external functions, you don't need to include anything, right? You don't need to include anything. You can just say uh, int main and just say return 0, right? And when you just compile it, it will compile because uh, you, like it's not necessary to include anything if you aren't using it from any external library. So those are the basics, and as you can see, it just returns 0, so there's nothing defined in the output. And yeah, so now let's go into, I will get into more details of how the compiling and the linking process happens in C++, but the first I will, uh, like, I don't want to discuss it in the first episode, right? So yeah, so let's first see all the data types in C++. So first let's start with bool. So boolean variable is takes two values, true or false or 0 or 1. So let's say uh, you say bool x is equal to, right, just say bool x is equal to true and bool y is equal to false. So mm, 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 what did we did wrong? Yeah. So yeah, bool x equal true and bool y is equal false. So they just take two values. You cannot say, you can say bool x is equal to 0. That means false. And bool x is equal to 1. That means true. But you cannot say bool x is equal to, for example, uh, a string. Just you cannot say that. So it will throw an error right now. But yeah, I mean, it isn't throwing an error, but it will throw it at a later stage. So when you say right, and just say, and let's say, let's print it out, whatever the value is, and let's see. Hmm, that is interesting. Yeah, so what happens is that, uh, as you can see, technically, in strict compilation process, it shouldn't happen. But what happens is that the S value, the compiler is intelligent these days, so it casts it into from a character or a string to a Boolean variable because it thinks that you must have thought before writing the statement, and so it just tries to infer what you did that did there. So, but technically, you should not do this. You should only give it one or zero, okay? And because if the if you run this code in another compiler or another system which does not do that, but you are assuming that it will, so code will break. So you shouldn't do that. And so this is the Boolean variable type. Next comes int. So that's quite simple. You can just say int a is equal to 1. So again, if you say int b is equal to 2.5, right? Now technically this statement is wrong, right? Because you cannot equate a so suppose it's a float, you cannot equate a float to an int, but again the compiler will cast the float down to an int, and it will just allocate or equate b to 2. So when you print it, let's do it right now. Just p. You know what? Just we will go into namespaces also soon, but right now, just trust me. And okay, just print the value, and you will see. There you go. Okay. So as I told you, you shouldn't uh, equate a float to an int in C++ because you will first of all lose the precision as you lost the precision when you did bool x is equal to s, you lost the precision. So basically what happened is that you wanted x equal to s, but what you got x equal to 1, right? So that's not the behavior that you wanted. So always try to make sure, because a lot of errors in C++ when you work with larger files happens because of that. So just make sure. And so this is int. Then you can also use float, and float f is equal to 3.14, for example. And now if you print f, it will print 3.14, and that's the way to print 3.14. Also, you have double for the double precision if you want more precision, and you can say that what's the value? So suppose g is equal to 9.81, something like that, right? If you want double to be that, and the same goes for double. You can print it here, and you got string s is equal to hello. So you can print string s here, and you get hello. And uh, yeah, I think these are the most primitive types that I've covered here. And the beauty of C++ is that you can also create your own data types if you want, and we will cover it at a later stage. So yeah, that's basically what I wanted to cover in my uh, like first part of the series. Uh, And yeah, so and another thing that I would like to add here is that suppose you have for example, you have a double here, right? And you want to um, suppose you want to equate f to b, right? F is a float and int, b is an int. So the best way to do is to just say b is equal to you have to cast it down. So there are numerous ways to cast something from a float to an int, from an int to a float, and all that stuff. One of the methods is, although this is not modern C++, but this is one of the methods. You just have to put the type that you want to cast it into inside brackets. So I want to cast f, right? I want to cast f into an int and equate it into, and so I want to put that value inside b, right? So I want to do that. So one second. Yeah. So as you can see, uh, this is casting, and this is one of the numerous ways to cast, but that's not what I recommend. This is just to give an overview how to cast, if like that this thing exists, but there are better ways to cast that I will discuss it in future episodes. So you get a variable f 3.14 and you cast it into an int, and you equate that value into b, and now when you uh, so just let me show you the difference. Oh, I actually built it. Yeah. Okay. So right, just let me show you, and yeah, we're ready to build. Okay, so as you can see, before b was 2, okay, that's expected because it was an int, but then you cast 3.14 to an int, and when you cast 3.14 to an int, it will be equal to 3, and then you get it to b, and you get 3 before and after. So yeah, these are the things that I wanted to cover in the first episode, and see you in the next one.